So today we'll be talking about feature engineering at scale with Dagger. And before we move further, a bit about me. So my name is Ravi and I'm basically the founder and principal architect of the Open DataOps Foundation. So let's talk about what is feature engineering, right? And in simple terms, according to me, it's the process of transforming raw data into high quality input signals that you can feed into your machine learning models. And if you look at overall feature engineering in an ML pipeline, so the way it starts is the raw data. You have the first raw data, and then you go through a transformation, and then you put it into feature store. And that is the part I kind of call it as like, I look at it as a feature engineering. And from feature store, you can kind of take it up to model serving and model training, right? So that's like high level overview of where the feature engineering kind of fits into the picture. Now, before we go further, like let's talk about what is the need of feature engineering, right? So one, I think, is the better feature leads to better flexibility, right? So if you have good data structure for your models, then it makes it easy for you to kind of choose models among themselves. And better feature also kind of then leads to simpler models, right? So because it's easy to pick the right parameters in the right models. And overall, if you look at it, right, if you have a better and composed feature engineering done and you have right features, that basically results to better results of your models. And if you look at some of the feature engineering challenges, right? So one that comes to top in my mind is inconsistency between your training and serving data. So the data that you have during offline training when you're serving your models, and then the data that you end up having during the serving, which is when your models are live. Another one is like managing data pipelines. So you don't want your data scientists to kind of start doing the managing of the data pipelines overall, right? And you have like a large team that kind of taking care of that. Another one is scaling data infrastructure of it, right? So now you have a lot of these feature engineering pipelines going on. How do you go about scaling the infrastructure of it where you have thousands of jobs running? And especially in the distributed organization where there are many teams spread across the organization, it becomes very tricky that how that feature engineering overall is being done by different data scientists, right? Some have certain other tool to kind of to go about the feature engineering. Someone is using Flink, someone is using XYZ tool, right? And then standardizing that pipeline and that infrastructure becomes tricky. And if it is not standardized, then the maintenance of that becomes like more tricky. Last piece is that like real-time features are not just something I think it just comes out of the box, right? You need like skilled data engineers to put those things together. Like you need to have someone knowing how the streaming pipelines work, how the tumble windows and hop windows and those kind of features kind of work, right? And data scientists at times are not aware about some of those things when they are writing or computing their features. And that's where you need kind of the core data engineering or software engineering skills to kind of fill that gap. And the same challenges that we talked about, if we turn it into the goals of a feature engineering platform, they should be solving those challenges. And then first one that can be solved is with the unified processing of streaming a batch. So if you don't want to have different queries and different data across your online and offline stores, then you like the best way to go about is that if you have a same query and the same processing logic for your streaming as well as the batch sources. Second one is that you don't want your data scientists to go about and worry about infrastructure. Like to them, it is completely agnostic. They go about writing their logic and then forget about how it is being spinned up and how the jobs are getting executed and what are the SLAs of it, right? They should not be worrying about any of those pieces. And next one is that elastic infrastructure. You don't want, if you have like a batch, let's say batch feature, if you have a batch job that is computing features and dumping into a store, you don't want infrastructure to lie down like after that job is finished. So you want to have the elastic infrastructure as part of your feature engineering platform. And I think this is still like if achievable goal, but like if you can have standardized and reusable way of how feature engineering is being done. One example could be is that if there is a same logic that is being used across multiple features, let's say computing S2 IDs from latitude and longitude, right? So you don't want all your data scientists to recompute or write that logic again and again. And you want some reusable ways to actually have those computations stored and being used by everyone. And the last piece is that I think you don't want any added skill for people to compute the real-time features. If they can do it into the standardized way, it's always better in productivity. So we at Gojek kind of have this Dagger as a platform, which we call stream processing made easy. And that allows people to basically transform, aggregate, and enrich data within ease of operation and reliability. So how Dagger works is basically it can pull data from multiple sources, your batch sources as well as your stream sources, like Parquet, which is the batch source, or your Kafka, which is like your real-time streaming source. And then Dagger allows you to basically write your logic, test it, monitor it right there. And the deployment of that is handled behind the scene from data scientists, either on Flink cluster or on Kubernetes clusters. And then it can send the data to multiple sinks. One of those being our feature stores, but it can also send it to your streaming sources if you want to put it back. But like a lot of people, data scientists use it to directly send it to feature store. So how does that ML pipeline look like with Dagger, right? So you have raw data coming from events or microservice or warehouses, and then usually that goes into your event streams like Kafka, and then Dagger pulls it from Kafka, and then it puts it into your feature store. So your data now after feature engineering computations is into the feature store. And from there, your training and then deployment pipeline can go. And then once the model are serving the inferences, the same log can be pulled back into event stream, which Dagger can utilize for more monitoring and then other use cases that we will talk about. So if you look at a slightly bit into the architecture of the Dagger, so it has like first piece is the consumer one, where it takes care of the consuming the data. Then it has preprocessor concept. So before even people start to write their logic in SQL, and if they want to have some pre-processing done through user-defined functions or other ways, or they want to pull data from asynchronous source, they can do it in preprocessor. Then there is main execution where people write their SQL query for transformation or feature engineering. And then they can, if they want to do after that, if they want to kind of talk to some external service or do post-processing, they can still do that. Like enrichment and such kind of things can be are capable in that case. And then final piece, it sends the data back to your sink. So certain key features of Daggers are, one, it's SQL first. So it does not ask people to start writing a lot of custom jobs on using Flink or any stream processing framework. People can simply come and write SQL queries. Another aspect is that it's not just standard SQL. So you can extend that basically by writing your user-defined functions and then using those functions into your SQL queries. So if you have a very complex logic that you can't achieve directly into SQL, you can write it with Python or Java, and then you can basically enrich that SQL using that UDF. Another one is like stream enrichment. So what basically that means is that if you have let's say message coming from Kafka and you want to reference some external source with it to enrich your stream, simple example could be is that let's say you have a booking order coming as an event and you want to attach the pricing from a particular model with that event. You can do the stream enrichment, call that particular external source, attach the pricing with it, and then pass it to forward. Next is the self-service. So people have this complete unified interface where they can simply come and write their feature engineering job, and it asks for you what data sources you want, what sync you want to send, and it shows you all your logs, output results, monitorings, if there is any exception, if you want to start and stop your job, or any templates, right? So entire processing or the job and then overall experience is packaged into the complete self-service platform. So for the people who, let's say, are not so fan of UI and then they have so many jobs kind of to manage, then like Dagger also provides a Git Ops way where you can write a simple YAML file and then you can just do the apply, and then that basically schedules that entire job. And after that, if you want to monitor the logs, you can still go to the UI, but it allows you people to basically simply write a YAML and then start basically executing their stream processing job. Yeah, so I think why SQL, right? So in terms of Dagger. So I think what we realized is that when people or data scientists start writing their feature transformation logic or processing of that, 95% of the use cases can be easily covered in SQL. And then whatever 3 or 4%, whatever is left, people end up writing, basically data scientists end up writing the UDFs and then still achieve with it. So I think what it still covers the 99% of the use cases, but makes the overall process much simpler. It's much easy to reason about. And then in a self-service platform, what also allows it is that people are not going to come and write their crazy jobs and then consume all your compute power, right? They're still writing SQL, which is kind of Turing complete in a key way. Another main thing is like UDFs. So we provide Python and Java, two programming languages, and people can come and write there. So for example, here you are looking at is that there is a GeoHash UDF that someone has written, which takes 3 parameters like latitude, longitude, and then it converts that entire thing into a GeoHash. Now, once this function is written, you can write it into SQL, and then anyone can start using it. Now, once single data scientists write this function, it's available for everyone to start consuming. So another thing that we kind of achieve on the data scientists achieve with the feature Dagger is that data masking. So let's take example, you have the production data coming in, and now you want to train your models into staging and then deploy it into the staging. So you don't want the production data and PII data to go into staging environment right away, right? And that's when you're doing your feature engineering. So what Dagger allows you to do the data masking. So there is one transformer in that where someone has written, let's say this transformer as hash transformer. So you can specify which column you want to mask, right? So if I want to say that, okay, mask all the email IDs or mask all the phone numbers, while I'm doing my feature transformation, I can simply specify this configuration along with the SQL query, and then Dagger basically take care of masking it. What that allows is that people to train their data directly onto the production data, but still making sure that no security or no PII data or sensitive fields are exposed to users. Another thing that we talk about is like the Dagger feature provides is the hybrid data source. So what we've seen is that I think in our case, a lot of feature engineering was done on stream processing data, right? A lot of things are coming in event, and most of the online models are working on the stream data. But for quick feedback, people still want to process data from, let's say, last 5 months or 4 months or 6 months, like that, right? So in that case, what ended happening is that they write the batch query, let's say something on top of BigQuery, or let's say on GCS data, cold storage data. They write that logic, and then when they're basically deploying their model on production, they end up converting that query into SQL Dagger query, and then deploying their model for basically online serving. What challenge it created is that people are writing 2 different queries in 2 different mechanisms on that. So what we ended up doing to solve that problem is introducing this hybrid source. So what you can do is you're writing your SQL query. It's the same exact query for batch data as well as for your stream data. But instead of working on stream or batch, it can work on hybrid, which basically means you can take today minus 4 month data to today minus 10 days data from your batch source, like let's say Parquet source. And from today minus 10 to up to today and going forward, you can start consuming from Kafka in real time. And Dagger behind the scene take care of switching this automatically. As soon as the batch data is consumed, it starts to go into stream data automatically without people worrying about changing their logic or doing anything. They just have to specify these 2 sources. That's it. So as I think some of this I already talked about. So for example, in this case, people are simply specifying one source type is the bounded one, which is your batch source. And then type of this is basically Parquet one. And second is your unbounded, which is Kafka source. And that's it. And apart from that, everything else remains the same. Their query remains the same. And people are actually able to backfill their historic data and then even join multiple stream across for complex use cases. Next, I think is stream enrichment one. So this is another feature that Dagger provide for making life of data scientist a bit easier. So let's say the pricing example I was talking about, right? So if you want to say that there is one booking event came in a stream job, in a streaming event, and I want to attach pricing or something else or surge pricing with it, and the surge pricing reference data that I need, it's stored in some Elasticsearch or let's say some other XYZ sources. So you can specify your external source and you say that Elasticsearch is my external source, and you specify the endpoint, and you can say, okay, map customer profile to this particular case, right? And what it allows you is to enrich that entire thing. So for example, you go to the booking and you want to add and attach customer ID or customer data with it, or even do the inferences from your model, you can do those kind of things. So basically same SQL query, just a bit of JSON configuration, and you can enrich your entire stream. So if I look at high level, how this looks is that, okay, you're getting data for your input to prediction model from Kafka, and then you get into Dagger. Dagger pulls the online feature from a feature store, makes a call to the model, fetch predictions, and enrich that output, enrich basically this prediction model input with the predictions and send back to Kafka. It can send back to other sources also. And then rest of the consumers can start to basically pick it from there. Right. So what it allows is basically people to do this stream inference and enrichment right out of the box without anyone else or data scientists or data engineers coming into the picture. So in terms of overall adoption at Dagger, so we have some 300 plus Dagger jobs running for purely feature engineering, which data scientists are writing on their own. And we have more than 50 data scientists spread across different teams who are writing these jobs to it. And overall Dagger, I think on the daily basis kind of presses around like 10 plus terabytes of the data. I think just a bit high level on Dagger. So Dagger is overall part of Open DataOps Foundation. And what Open DataOps Foundation is basically, it's a suite of products that allows people to discover, transform, analyze, and secure data. So we have different products as part of this. And Open DataOps Foundation is, I think, is built with a slightly different approach where it's not about what tool you are using, but how people want to use it, right? So first piece is that anyone joins your organization, they want to discover data. And that's the first step. Second step is that once they understand what data exists, then they want to understand it. How's the quality? How's the lineage? And third is that they want to process on it. And then Dagger is basically fits into the process part where people are processing, transforming, and analyzing data. And then last is you take it back to your business and apply. Yeah. So it's a bunch of tools put together, and then that's what we call as an Open DataOps Foundation. So these tools are kind of categorized in three major categories. One is around data lifecycle. So let's say, for example, one is for data ingestion. Dagger is what we talked about today, which makes data scientists' life super easy to do the feature engineering and feature transformation and enrichment. And then there are other tools around transformation as well as around data management, and then basically overall reliability and schema management. So Open DataOps Foundation and Daggers are already powering like large data platform teams, like for example, Gojek, Midtrans, Mapan, and Mocha. Some of these companies and organizations are already using these tools that I just talked about. And all of these things are open source with Apache 2.0 license and in a vendor neutral space. And we have like somewhere around 200 plus contributors, and then it's growing with 80% growth. And in last year, we had around like 2000 plus commits into it. And then like across GitHub and Slack, we have like 1000 plus community members overall for it. So I think at last, I would love to kind of take feedback on what all we talked about and what all we discussed and how we're solving these problems. And then, anyone have any questions, feel free to get involved by checking out GitHub organization for this. And also feel free to join the Slack community and then let us know for any questions. That's all from my side. Thank you so much for having me.